Okay, now let us take the other problem, which says that you have to find the remainder which will be left out when you do this calculation, that is 8 raised to power 2n minus 62 raised to power 2n, and you divided this whole term by 9. Okay, so this is the calculation that has to be done. So first of all, you have to look out, I suppose you must have done these sort of questions. What you need to do is, first of all, for divisibility by 9, you have to make each of these terms a factor of 9. Okay, this is the trick basically that we use in these kind of questions. So 8 can be easily tricked into 9 factor if I can write 8 is equal to 9 minus 1. Alright, this is a very simple step. Alright, and this could be written as 63 minus 1 because we know that 63 is a multiple of 9. Okay, because if 63 is there, that means it is divisible by 9. But also see, what we can do over here is that if I write here as 8, it is raised to power 2n. If I make it 8 2 inside and n like this, I can also write 64 raised to power n, and now I can write 64 raised to power n as 63 plus 1 raised to power n. Alright, I suppose you must have understood what I am doing here. Alright, so, and this is 2n plus 1. Alright, so this is the whole scenario now. Now I just need to calculate these two things, that is, I have to see 63 plus 1 raised to power n minus 63 minus 1 raised to power 2n plus 1. Okay, so now this is the thing that I have to be calculated. Okay, now if I write this as 1 plus 63 raised to power n, this is one and the same thing, and if I take minus inside, okay, I can take, because this is an odd power, so minus will remain minus inside, so this will be minus 1 by 63 raised to power 2n plus 1. Okay, so I can take the power in this fashion as well. I'll make you understand why I have done this step after I solve this question. So now, applying the binomial theorem, what I can say, the first term of this expansion would be 1. The next term is going to be NC1 63 plus NC2 63 square, and after on every term will have 63's factor. Okay, so this is the expansion of this series. Plus, if I do this, this will be 1 minus 2NC1 63, and this will have alternate plus minus. This will be plus 2n plus 1 C2 63 square and minus, so on, it will go on. Okay, so now if I add these two terms, it will be 1 plus 1 2, and I can take in all these terms, this term, this one, 63 common, 63, and the remaining term will be NC1 minus 2n plus 1 C1 plus NC2 okay, plus 2n plus 1 C2, and so on forth. Okay, so we know that if 63 is there in outside, this is obviously divisible by 9. This is there is no confusion about this, because 63 is a factor of 9. So the remainder obviously will be 2 in this case. Okay, so that means the answer option B is the correct one. Now coming back to the point that why I have written this in this format is to make clear that if I expand the series by 63 plus 1, so it becomes a little bit difficult to understand. You have to write the first term as 63 raised to power n, then NC1 63 raised to power n minus 1. So it's basically a tedious task to write this thing, and you might not even write plus 1 in the end, because you have the habit of writing dot dot dot. Okay, so to remove that silly error of yours, always make sure that you write any expansion in the form of 1 plus a raised to power n rather than a plus 1, though at times this equation is required, but generally you should follow this one. Alright, so I suppose now you must be clear with this example. Do this thoroughly, because there are many kind of examples that generally come in each year, though sometimes in AIEEE, sometimes in regional engineering exams. IT might even ask these kinds of questions, but in a different fashion, not that easy level. So you should be basically knowing the fact that what has to be done. Like I have used that, you have to make factors of 9, that's it. Okay.